Hello, everyone. My name is Ian Morris. I work with Career Services at Central Washington University in a role that's largely data-driven. Today, I gave a webinar on what I was calling Excel 102, some intermediate strategies for working with Excel and some basic formulas to create a little bit more dynamic worksheets. I got a large response from the course asking me to record this video to post it online for reference, so that's what you guys are seeing now. In advance, I apologize. This is not going to be the most visually stimulating presentation. But what my goal here is really not to make you an expert at all these topics, but instead to really introduce you to some of the tools and applications of a little bit more powerful level formulas in Excel, and to introduce you to the terminology so that if you really think you have an application or use of one of these, you can kind of pursue that knowledge with at least the tip of the iceberg, sort of awareness of what it does, how to use it, maybe even how to apply it, and the key terms you would need to find more information about it. So with that being said, I'll just jump right on in. So the first thing I really wanted to mention was kind of the difference between Excel and Google Sheets. Most people know Excel at this point. It's part of the Microsoft Office Suite package. It's a paid software, but it's really a sort of an industry standard across a range of industries. Google Sheets is a new player to the field, sort of. They've really risen in sort of awareness and use and application in recent years. And it really is very similar to Excel. It has a lot of the same functionality, a lot of the same features. In some ways that I find it's much better, in other ways it's not. To be perfectly candid, I am a Google Sheets person myself. I have largely abandoned Excel for Google Sheets. That being said, there are certain applications I prefer Excel for, and we'll talk about that. I also think that Excel does have a little bit more robust of a platform in terms of advanced formulas and functionality. Google is sort of mild, but it's great for basic spreadsheets, dashboards, things of that nature. So the first difference is really just the pay factor. Excel is part of Microsoft Office Suite, so it is generally a paid package you would get. Google Sheets is usually free and online, and like a lot of data, or a lot of Google stuff, it's free because you don't necessarily own some of your data. So because of that, I really would not put sensitive information in Google, like banking information, student information, personally identifiable details. Not really what that kind of stuff in there. Things like inventory management or just doing a cost benefits analysis, that's fine for me to put in Google, because to me that's not sensitive data. But things that are sensitive, like if I had a list of students that I was working with at a university, I would probably use Excel because I know I've purchased that software, it's stored on my computer, and I know the data rights attached to it. So that's just a note about that. The other thing to note is cloud versus local. So Excel and Microsoft is getting much better about creating collaborative cloud environments. But in general, Excel is a local-based project. That means that you'd work on your Excel sheet on your computer, you save it on your computer, and if you're working with somebody else, you'd send them a copy, they would work on it, send it back to you, and then you guys can merge copies or reconcile as you need to. Google Sheets, one of the things that makes it really powerful and useful is it's cloud-based, so it's online. You always go to this website to find your spreadsheets, and they're all there. And it's live collaborative. Because you're online on the same sheet at the same time, you can see in real time the edits that someone else is making on your Google Sheet. You can also set controls where this person can only view it or this person can edit it. So there's sort of a lot of teamwork potential there. Again, Excel is really working on this and expanding this model, but they're doing it sort of as a response to what Google had sort of led the pack in that term of collaborative spreadsheets. But again, it's a very useful tool if you find yourself working with non-sensitive data in groups across distances. Being able to work in live time on the same sheet is very, very helpful. Array formulas we're not going to go into in this presentation. They are a more complex form, an incredibly powerful form of formula you can use in Excel. What I find is Google has a lot of easier ways to do array formulas. An example of an array formula might be to show me a list of each unique name on this list, right? So in Google, I would just type unique, and it would generate that list for me. In Excel, I'd have to use an array formula that has multiple variables, a whole lot of information. So from the user experience, it's actually a little easier to handle some of the basic stuff in Google Sheets, but Excel is actually much more involved and has much more depth in terms of what it can do with these things. So it's more powerful ultimately, although it has a little bit more complex user interface in navigating those. The last thing to note is just how you would share these documents. Again, Excel is a document that you would have to send to somebody else via email. You both have your own versions of it. And if you guys had different edits that contradict one another, you need to decide how you handle that when you share the sheets back and forth. Google Sheets, you'd share via a URL that it provides you or via an email. And again, it's live time. So if one of you makes an edit, the other sees it at that moment. So just different dynamics. They both have their uses and applications, but be aware that I'm not traditionally an Excel expert. I really spend most of my time in Google Sheets at this point. But one of the things that I really want to drive home is almost everything we're going to talk about here work exactly the same in both of these. Even the formulas are pretty much exactly the same. So that's just a quick note about it. I think it's just good to, so many people are aware of Excel and know Excel, but it's just good to know there is other tools out there if your budget it doesn't allow it, or if you are working with teams remotely on non-sensitive data. So before we really get into the technicals and some of the more complicated issues, I just wanted to show a neat little thing that can be a real time saver. I'm surprised that many people don't realize that Excel actually has a powerful pattern recognition software that can save you a lot of time when you're entering data that's a pattern. So in this case, I have some dates. I can actually just click this little box here in the corner, drag it down, and it will actually auto-populate those things for me. Same thing with numbers. If I'm just counting, it recognizes that. More complex dates can do the same thing there. Even mathematical patterns. Here we're adding 2 across the thing. Carries that pattern forward without a problem. Even formulas. In this case, I have some sum formulas that are just adding these 2 rows. But if I drag that down, it dynamically recognizes that formula. Now it's adding these rows, or these rows, or these rows. So again, this is a really simple trick, but it's very helpful if you find that you're entering things where maybe one column is dates. You don't have to type those. Just type 1 or 2, and then you can drag it down. That will come into play a little bit later in this sheet. It's just a nice little sort of tip to make things move a little smoother for you. So jumping into the sum functions, the basic one I think most people know, it's just if you want to count a given row. So you'd say equals, and for those of you who don't know, anytime you put equals, I have these quotation marks here so that it doesn't actually trigger a formula. But generally, if this wasn't here and I just said equals, that equal sign really tells Excel this is a formula. And if I hit tab now, you'll see that rather than giving me the text, it's actually giving me the output of the formula. So just for display purposes on all of these, what I have is I have a visual version you can see here, as well as the actual formula running below it. So that being said, sum is simple. Sum, you would just sort of say the areas you want to look at. In this case, I'm looking at B7 to B20, so 7 all the way down to 20. And really, I'm looking for just the sum of those numbers. So this tells me right here that if I add all these numbers up, I get 44. That one's pretty basic. Most people know that, are pretty comfortable with that. Where that starts getting more useful is when you can sum by specific criteria. So that's where the Sumif formula comes in. So say I want to sum not just the number of fruit in the store, but say I want to know exactly how many apples we have in the store. Well, that's where this formula Sumif comes in hand. So just like last time, you'd start with the equals, sum, now you add if. And what you're going to do is you're going to first indicate the criteria you're looking for. So in this case, or where you're looking for it. So first, I'm looking in row G. This is my fruit row. And I'm looking for the word apple. So I've told it where to look and what I'm looking for. And then what I'm going to tell it is where I want to sum whenever I find that match, which is row F. So again, I'm saying look here in the fruit row, and if it says apple, then add this to the sum. So what we get is a sum of 11, which reflects these 4 apples. Now again, this is a dynamic sheet, so if I was to change one of these to peach, suddenly my counts are very different. I'm going to do Control Undo just to keep my sheet the same. So that's pretty useful. There's a lot of applications when you want to find a sum or a count by a specific criteria. But you can actually go one step further. Sometimes there's multiple criteria you need. So in this case, maybe we want to figure out how many apples we have in store 1 location. Okay, that's a pretty reasonable challenge if you're trying to manage a distribution line or merchandising for a retail chain. So you can handle pretty much as many of these criteria as you want just by extending the Sumifs formula. So here we have another example, and one of the things that you'll notice here is on this one, when I say what to count, I say that last, right? Well, in Sumifs, I'm actually going to start. I'm going to say I want to count row J, which is these J. So count anything in that row if row K, which is my fruit here, equals apple. Let me just highlight that so we can see it. If row K equals apple, and if L, which is, if you look here, the store, equals store 1. So what I'm saying is count J if it's an apple in store 1. And you see here my count is 3, if apple store 1, apple store 1. It's not counting this one because it doesn't meet both criteria. It's worth noting that Sumif is an and, not an or, meaning it has to meet all of these criteria in order to be summed, or counted in this case. So That's the sum formulas. Again, not incredibly complex, but a very powerful tool for a lot of applications. Moving on to the count formulas, which are very similar to the sum, but rather than count or summing these, mathematically adding each one down the line, I'm just going to count how many instances there are. So the first one here is a basic count. I just want to know how many rows I have here. And it looks like I have 14, right? Again, it's equal, lets me know it's a formula, just the word count and the range that I want to count in. Now again, say I want to do it by criteria. I want to know how many log entries, not how many apples we have, but how many log entries we have that were apples. Okay, well now I'm going to do the countif, and I'm not going to identify a row that I'm counting because it's just looking for instances of match. So what I'm saying is I'm looking in G, which is the fruit rows, for apple, and every time it's going to find an apple in G, it's going to count that as one instance. So 1, 2, 3, and 4, and lo and behold, we have 4. All right, so moving along to countifs. I know this is going to be a shocker, but this is just the same as the sumifs we talked about. So again, it's adding that extra layer of what you're going to count based on multiple criteria. So you'd start with your equals, you go to your countifs, there's a little s as the extra one there, and then you give your criteria and what you're searching, or the range and criteria. So in row L, I seem to have messed this one up here a little bit. Actually, look at the formula here. I'm clicking down here. And when I click down here, one thing to note is there's a formula bar up here that actually shows the formula. I've made a mistake here, so we're going to look at the formula bar on this one. Notice that when I click on it too, it highlights the rows, so it gives me a lot of visual cues to help. So in this case, what I'm counting is row, see up here, it's K8 through K21. So I'm looking at K, that is the fruit row, and I'm looking in that range for the word apple. Then over here in the L row, L8 to L21, that's this red highlighted section, I'm looking for the word store 1. So anywhere I find those two criteria, I'm going to count that as an instance, and this will become my total, which is 2. There's 1 instance, there's 2 instances. Pretty simple and straightforward. So let's add a little layer to that. So we showed count earlier, counting. Now count counts numbers, and that includes negative numbers, 0 numbers, all kinds of things. What it doesn't count, you might notice here, is letters. For instance, if these were actually numbers instead, that would change my count. But say you have other entries in there, or maybe you're just trying to tally the average of males versus females or something. Well, count won't catch that. That's when you'd actually have to use this other formula called count A. And that counts not the number of numbers in it, instead it counts the number of entries in it. So notice that blank spaces don't count for either of these. But in this one, letters will count just the same as numbers. So it's really just saying how many of these cells actually have something in them, whatever that is. So here's an example of combining some of these things in a way that's pretty common and fairly useful. So here I have a series of numbers. Say I want to do a dynamic rolling average. Maybe every day I enter our sales and I want to know what our sales average is, or the number of hours my employees are working per week, and I want to get an average of this. So what you'd have to do is, first thing I have here is I have a count. I'm counting, and count A, I could have used just count down this. I'll actually show you that just because it's the same. There we go. So here we have the count. Looks like there's 11 of them. And this is dynamic because as I add more of these, if you notice my range that I've indicated here, it goes all the way down to 22, which is here down to there. So any numbers that I add, as long as the range is looking for that, it's going to be dynamically added to what I'm doing. Great. Now I've got a nice dynamic count. Now I can use my sum formula to combine those and get a count of what is all these added together. All right, so now I know there's 14 instances, and that adds together to 1694 here. Well, just by dividing the sum divided by the count, it gives me that nice rolling average. And again, as you guys have probably seen as I went along through this, that's a very dynamic sheet that's using the sum formula, the count formulas to generate a rolling average based on the numbers input, and can be a really useful tool in a lot of analytics and reporting. So that's just an application of some basic concepts there. So from here, we kind of go into a little bit deeper waters, and things get a tad bit more confusing. So again, keep in mind, I'm not expecting you guys to be an expert at this. I myself am not. I just want you to know that these things exist and know that you can search for them if you really do have an application for these. So the first one to note is wildcards. So sometimes you don't know exactly what you're searching for. Maybe you're searching for every time, say you have a sales or a cataloging system at your company that starts with 2, 3 for a certain product and then has some series of numbers. If you wanted to pull out every one of that product, you would need a search that basically says anything that starts with 2, 3 and then has something else. That's kind of the use of wildcards. Is anytime there's that and something else, it's a wildcard character, and there's different versions of these. The first one we'll talk about is just a question mark. So anytime you put a question mark in a formula, what that's going to represent is any kind of character can be there. So here we have an example where we're using a Countif. So we're going to get a count of the number of times we find this. And we're looking in B7 to B20. So we're looking in this range. And what I'm looking for here is a word that starts with a TR, has any kind of a letter, and then a Y. So try, for example, doesn't trigger this because there is no letter in between. The wildcard says there needs to be something between that R and a Y, and there's just one something, but it can be anything. So Troy works, Trey works, other Trey works, other Troy works. It catches those and it counts them, but try it doesn't because there's nothing in there. Trolley it doesn't because there's too much stuff there. So it's using that wildcard character to match everything but that, but it recognizes there should be one character there. Now, sometimes you don't necessarily know how many characters there are. So here's another example using the exact same thing. Again, we're doing Countif, we're giving it a range, but this time rather than a question mark, we're using the asterisk symbol. What this means is that it means it could be any number of random characters there. So this would match any word that starts with TR and ends with Y, no matter what was in the middle of it. So that matches all of these, because any of these start with TR and end with Y. The only one that doesn't is travel. So this can be used in all kinds of ways. This is an example in the middle, but you could really just say, if you did something like this where it was just asterisk Y, you would be saying any word whatsoever that ends with a Y. Or in the example of our catalog system where, say, every product of a certain type starts with a 32 and then a series of numbers, I could put 32 here. And now what I'm saying is I'm looking for any instance that says 32 and then has a series of numbers. So these can be really powerful when you're trying to look for data that you don't necessarily have as clearly defined or that might have broad subcategories within it that are easily coded like that. So wildcard. Now, sometimes there are instances where maybe you want to search for one of these actual characters, and maybe you are looking for the exclamation point and not or the question mark and not a wildcard. So there's a way that you would avoid or tell the system that you're not trying to make this a wildcard. And the way you do that is with a little tilde sign. It's a little tilde or whatever. It's right here. Putting this before one of the wildcards is saying this is not a wildcard. I'm actually looking for an asterisk, or I'm actually looking for a question mark. So here we have a little bit more complicated example. I like to make this a little confusing for you guys. But again, we're doing a Countif. So I'm counting how many times there is an instance that matches this. I'm looking at F7 to 21, so that's 7 to 21 right here. And what I'm looking for, and the quotes always tell me what I'm looking for, is I'm looking for any number of any letters, then the tilde, and this right here tells me that I'm actually looking for a question mark, not a wildcard, because the little tilde in front of it tells me that I'm looking for a question mark, and then any number of characters. So really what this is looking for is any words or any matches that have a question mark at all anywhere in the word. It can be before, it can be after, it can be whatever. So here's some interesting examples of that. How are you, it wouldn't recognize because there's no question mark in it. But how are you with a question mark, it does. Or if the question mark's over here, this question mark good. That one it would also read because it recognizes there's a question mark in there. Notice that it says there's 5 instances. Here I have, I believe 7. There's 7 potential matches, but it's recognizing that only 5 of them actually have that. Now, if I didn't have that little tilde symbol in there, now this would literally match everything. It's saying any number of any character and then one character of any character and then any number of any character. So as long as it had at least one character, it would count here. So just to show you that, we're actually going to change the formula up here. Let's get rid of the tilde. And what you'll see is now it's counting all 7 because all 7 of these contain at least one digit. So by adding that little tilde sign, we say, no, I'm not looking for the single wildcard. I am looking actually for a question mark. And now it says, oh, okay, there's only 5 question marks. Again, those are wildcards. To be honest with you, I don't use them much frequently myself, but there are certainly applications for them and some scenarios that these can be helpful. So I'm not expecting you to be a wildcard expert, but just know if you ever find a situation where a wildcard would be helpful for you, there's some great tutorials on how to use these all over the internet. And that moves us to my favorite formula, hands down, Vlookup. Vlookup is admittedly a little bit confusing, and it has some weird quirks sometimes, but this is an incredibly powerful formula you can use in almost any industry I've worked in. You can use this when you're trying to merge lists that have a shared data point to make one sort of master list or to fill in data gaps. Or you can use this if you're cross-referencing two lists to try and figure out where they match or where there's missing items on one list. So we'll talk about those examples real quick. So here we have the types of data we would use. In this case, I have one list where I have names and I have emails. Over here, I have another list where I have names and I have phone numbers. If I wanted to create a master list of these, I would be able to do so using Vlookup because they share a data point. They both have names. So the way I would do that is I would pick which one I wanted to start. In this case, I'm starting with list 1. So I've got the name and I've got the email. And I would add my Vlookup formula, which is right here in these yellow sections. And I would tell it to match based on this row to populate this row. So we're going to walk through what that looks like. So here's a Vlookup formula. Again, you start with equals because that's telling Excel that you're doing a formula. You would type the word Vlookup. And then this is when it seems a little daunting at first, but it really is quite easy. And once you've done it a few times, you get much more comfortable with it. But here is the actual Vlookup formula now. First, you start by saying what you want to match. In this case, I want to match the information that's in B, the name, right? Because that's the data point I have in both sets. So that's what I want to be looking for, the name. Then you want to tell it where you want to look for this. Now, you can look for this in all kinds of places, in other sheet or in other tabs down here. In Google Sheets, I can often use across other sheets, so I will look to a sheet that's not even on this sheet. But in this case, we're just going to look at the other rows, right? So we're trying to match row B. That's the first thing there. And then we're looking in range E and F for those matches. Okay, so it's going to find that match in row E. But then the reason that we pick 2 is what I want it to return has to be in that same range. So I pick E and F as my range, and I tell it that I want it to return the second item in that range. So going back to the range, E and F, the reason I put both is I have to put the matching range. So I have to include this range because that's what's going to match to B. So E has to be there. But what I really want is actually F. So I'm adding this range, E to F, and I'm telling it that I want the second item in the range. That's what I want it to return. That's what this 2 here is. Now, if I just wanted it to return name again, which would be a little redundant, I could put 1. And then anywhere there was a match for Bob on here, it's like, oh, there's a Bob and here's a Bob. It would populate Bob. It's not very helpful to me, though. So I would prefer I put 2 so that it's grabbing the second item in that range. 1, 2. That's going to be number. And then this last question. I will tell you right now that I have been using this sheet for a long time. I've been using Vlookup for many years, and it's always been false for me. What this question is asking you is, are you willing to accept an approximate match, a near match? So, like the word Joe here. Joel might be a no match, a near match. Joey might be a near match. But I'm usually not looking for a near match. I'm usually looking for an exact match. And because of that, I always put false. So this is a true or false question at the end. It says, are you okay with a near match? And if you want an exact match, your answer is false. And again, in my uses for this, it is almost always false. So if you remember nothing else, just write the word false and don't ask why. It's helpful. You can delve into that a little further if you want. But usually if you're matching, you're looking for an exact match. So here we are. We actually have one in use. It said Vlookup on B. All right, so we're matching the name. This time we're using E to F. There we go, and it's all highlighted. E has the name where it matches, and F has the data I want. I tell it to take that second row of the data I want and to feed that over here, and I tell it false, meaning it should be an exact match. So when I hit tab, look at that, it grabs the number because it saw Bob matches Bob, and it populates the number based on the second list. And again, I showed you guys before how we can drag down to populate. So now if I drag this down, it's going to do that same thing. It's going to say, hey, Joe matches Joe, and this is Joe's number, so let's populate that here. Very, very useful tool, very helpful. This is probably how I've used it 80% of the time, is I'll have different data sheets from different departments or different agencies, and I'm really reconciling the data sheets to create one master sheet that has all the information, or to compare them to see where one sheet might, or to fill in gaps that I might not have. If I have a sheet of emails, I might be able to use that Vlookup from that sheet to fill in another contact list I have that's missing emails. Again, very, very useful tool. I find we often keep data segregated in multiple places, so being able to put that data together and figure out what's relevant within a broader context can be really useful. The other place I really enjoy using this is as a cross-referencing tool. So as a real-world example, say I did an event and I kept roll of who attended my event. And now a teacher emails me and says, hey, I sent my class to your event. Can you tell me of this list, of the roster of my class that I'm sending you, how many of them were at your event? So in this case, what that would be is, here is my event sign-in sheet, right? Bob, Joe, Zach, and Amelia signed up. Here's the teacher's roster they sent me. Sam, Zach, Pete. Well, I can actually use a VLOOKUP to quickly compare my two lists. So what I do is I create a VLOOKUP formula just as I have, and I tell it that if I can find a match for Sam, to populate the email here. But if it doesn't find a match, it's going to add this little NA. And let's go and show you. This is a VLOOKUP formula, just like the last one. So we got equals VLOOKUP. And this time I'm looking in row L. Where is that? L. See here, I'm trying to match right here at this name. And I'm looking in the range H to I for the matches. And what I want it to return is not the H, but I want it to return I, which is the second in this range. Now, had my range been that as my range, it would be the 1, 2, 3, 4th in the range. So these numbers can be higher. In this case, I'm just doing the 2. But there we go. So it's the second item. And again, it's false because I want an exact match. So now I've got the VLOOKUP and it returns NA because there is no match for Sam on my roster. But if I was to take this, drag it down so that that formula populates, hey, look, there is a match for Zach, there's a match for Bob, not a match for Pete. So now I can really quickly cross-reference two lists and get a sense of where they overline and where they don't. Now, when we're looking at 4, I understand this seems a little unnecessary. But when we're talking about cross-referencing a list of 1,000 and a list of 2,000, this can be the difference between hours of work trying to figure out where they match and don't match. So again, that's a VLOOKUP. This can be a very intimidating thing for a lot of people. I know myself, I took several times, and I even sometimes still have to go back and look up the order of these things. But just know that it's great for merging lists that have a shared data point, or for comparing two lists that have a shared data point to see where they do and don't match up. The formula, there is so many tutorials for VLOOKUP online. They're wonderful. Go track them down. The only thing I would say is be mindful of the year of the tutorial. Excel evolves quickly, so sometimes you might find outdated tutorials. If you can find one within the last 2 years, that's generally preferable. All right, so moving on to the last section here is pivot tables. I will be perfectly candid with you and say that I have rarely ever used pivot tables, and I don't really consider myself a strong user of pivot tables, but these are very, very popular among many Excel users, and they're a very useful tool for data science or for accounting. So I will introduce you to the basics, and I encourage you guys to do your own exploring. But here we have a sample data set that we took from our store data earlier. We've got, number of products sold, we've got the type of product and the store location. Looking at it like this, it's really hard to glean much information from it. There's various things I could manually do to curate the data to make it look more visible or to understand it, but pivot tables allow an easier way for us to manipulate and visualize data. So here's an example of a pivot table. Now, rather than just a list of store orange numbers, I can actually look at this pivot table and I can see of apples, there's 2 in store 1, 8 in store 2, and we have a total of 10 apples. This is a much easier data form to digest. It's much more understandable, and it just provides a lot more metadata that wasn't in the previous version. And creating this was really wonderfully simple. So what I'm going to show you is going back to the data. You just highlight the data set that you want. There you go. And you go to Insert, Pivot Table. First thing it'll say is, what range or what data do you have? Because I've already selected my data, that's already populated for me. If you hadn't pre-selected, you could type it in if you're feeling that skilled and brave. Then it will ask, do you want to add it to the sheet we're on or create a new one? I will always say a new one just because I don't want to muck up my current process. Go and say OK. And it creates a blank pivot table for you. You get this nice sidebar here as well. And the sidebar has pretty much this is where all the magic happens. This is kind of a drag and drop analytics. If you ever worked with Tableau, it's very similar to what they use, just with much less sort of graphics and functionality to it because this is not as expensive a product, to be honest. But pivot tables. So you start by getting the data sets that you have. I've got the number of items, I've got the type of item, and I've got the store item, right? So by checking these, it'll automatically populate these charts to the best of its ability with what it thinks you want. And actually, order matters to some extent when you're doing this. So you can play around with different things to try and get a sense of it. But as you can see, it populated that data for me. Now, when I click on it, it brings this up. If this goes away for any reason, just click back on the data on the pivot table and it will reappear. But now I can play around with this a little bit more. Maybe I actually want to know store as a row feature. So I just drag that data set down to rows. And now it's created this whole new thing where you see these rows, store 1, store 2. So I can see apples sorted by rows, by stores and rows. Maybe I like stores as columns. Well, now I can see store 1, store 2 for apples. You could do this with any of these data points. You can also do calculated fields. If you look right now, there's sum1. This is where we're getting these totals, is it's totaling the counts for them. But we can also add various things. So maybe I want to count the store. Oh, I already have count of stores, don't I? Let's see, what else could we count here? Well, yeah, let's do another value. Let's count how many apples there are, right? So I'm gonna take apples, I'm gonna drag it into my value section, right? So now we've got the total count of apples. There we go. I've got a totaling bar. But maybe I don't want the total count. Maybe I want something different. Maybe I want a sum of apples. I can right-click on this and I can say field settings. And I have all these options. I can tell it that I want it to do the sum of them, the average of them, the max of them, the min of them, who has the most apples. Oh, well, that didn't seem to work out well for me. But again, I'm not a pivot table expert here. The point I wanted to show you guys is how this works, how easy it is to create the initial pivot table. And then really it's kind of just a drag and drop adventure to see if you can visualize your data in a way that tells a story or shows information that you might not have been able to see from just the basic datasheet format. So again, from that to that, one of these is much more useful for casual observation and analysis. You can do this with all kinds of things too. So here's another example of pivot table where I've got 4 criteria, in addition to the store, the fruit, the count, I've also got GMO or non-GMO. And here's another pivot table where I've tried to visualize that. You'll see for apples, how many GMO apples do we have in a given store? How many non-GMO apples do we have for a given store? Just like last time, you can play around and drag these in different criteria, see what visualization works best for what you're trying to do. You can turn off data points. So a lot of versatility. Again, I'm definitely not a pivot table expert. There's also a lot of videos on this. I just wanted you to be aware of really, one, how easy it is to actually get started with a pivot table. Just select it, say insert and pivot table, say okay, and then just start playing with your data. And really, it's a trial and error process. There are some great tutorials that can get you a little more on point, but I think there's a lot of value in just going in here and kind of clicking around and seeing what works and what doesn't work and what kind of data comes back at you. So that's kind of the summary of my short introduction video. Again, I'm not trying to get any of you guys to be experts at all this. I just want you to be aware that there is some really powerful, useful tools out there, and to have a basic understanding of kind of what they are, what they're called, and what their applications are. So thank you for watching the video. I hope you find it helpful, and I welcome any of you guys to reach out to me at ian.morris@cwu.edu if you have additional questions. Thank you.